Our journey begins with a simple act, looking up at the night sky. What we see is a tiny fraction of an immense reality. Our universe is staggeringly vast, containing at least 2 trillion galaxies, each a sprawling city of stars. Our own galaxy, the Milky Way, holds up to 400 billion suns. If you tried to count them, one per second, it would take you over 12,000 years. Now, imagine that for every grain of sand on every beach on Earth, there are about 10,000 stars out there in the cosmos. This isn't just an empty expanse, it's an almost infinite canvas filled with potential worlds, waiting for us to ask the right questions. The sheer scale of it all suggests that anything that can happen will happen somewhere. So where is everyone? For decades, we believed our solar system was unique. But now, thanks to powerful telescopes like Kepler and the James Webb Space Telescope, we know the galaxy is rich with planets. We've discovered thousands of exoplanets, and we estimate there are more planets than stars. Many of these worlds orbit within the habitable zone, often called the Goldilocks zone, where conditions are just right, not too hot, not too cold, for liquid water to exist. Liquid water is the key ingredient for life as we know it. Based on current data, scientists predict there could be as many as 40 billion Earth-sized planets in these perfect zones within our galaxy alone. With so many potential cradles for life, it seems statistically inevitable that some of them would have given rise to living organisms. The universe is not only vast in space, but also in time. It's about 13.8 billion years old. Our Milky Way galaxy formed shortly after, and our own star, the Sun, is a relative newcomer at just 4.6 billion years old. Life on Earth took about 1 billion years to begin, and complex life has only existed for a fraction of that time. But many stars in our galaxy are far older than our Sun. This means that life on other worlds could have had a head start of 1, 2, or even 5 billion years. Imagine a civilization with 1 billion-year technological advantage over us. What would they be capable of? Their presence should be obvious. They would have had more than enough time to colonize their star system, and eventually, the entire galaxy. In the 1960s, astronomer Frank Drake tried to quantify this probability. He developed the Drake equation, a framework to estimate the number of active, technologically advanced civilizations in the Milky Way. It considers factors like the rate of star formation, the fraction of those stars with planets, the number of planets that could support life, and the fraction of life that develops intelligence and technology. While many of these values are still unknown, the equation is a powerful tool for thinking about the problem. Even when you plug in very pessimistic and conservative numbers, the math often suggests that we shouldn't be alone. Our galaxy should, in theory, be home to at least a handful of other intelligent species. Their existence seems logical, almost mathematically required. This brings us to a sunny day in 1950 at the Los Alamos National Laboratory. A brilliant physicist, Enrico Fermi, was having lunch with his colleagues. They were discussing recent UFO sightings and the exciting possibility of interstellar travel. The mood was optimistic. It felt like humanity was on the verge of reaching for the stars. In the middle of this enthusiastic conversation, Fermi fell silent for a moment, then asked a simple yet earth-shattering question. "But where is everybody?" His colleagues laughed, but the weight of the question quickly sank in. If the universe is so old and so large, and interstellar travel is possible, then someone should have been here by now. That innocent lunchtime question perfectly framed one of the most profound paradoxes in science. This is the heart of the Fermi Paradox, the stark contradiction between high probability and the absolute lack of evidence. We call it the Great Silence. For over 60 years, astronomers with the SETI project, the Search for Extraterrestrial Intelligence, have been scanning the skies with powerful radio telescopes, listening for a signal, a whisper, a single artificial blip from another civilization. But they have found nothing. Complete and utter silence. We have sent our own messages out into the void, like the Arecibo message, and launched probes like the Voyager spacecraft with golden records attached. Still, no reply. The silence is deafening, and it demands an explanation. Why haven't we heard from anyone? What does this cosmic silence mean for humanity?
One of the most compelling and perhaps unsettling answers is the concept of the Great Filter. This theory, proposed by economist Robin Hanson, suggests that on the long evolutionary path from simple life to a galaxy-spanning super-civilization, there is a wall, a filter, that is almost impossible to get through. This filter is a challenge or barrier so difficult that it eliminates the vast majority of life that attempts to pass it. The existence of a great filter could explain why the universe appears so empty. It implies that something is preventing civilizations from emerging or surviving long enough to make their presence known across the stars. The critical question for us is, where in our timeline is this filter located? Is the great filter behind us? Perhaps the emergence of life itself is the barrier. We still don't fully understand how the first living cell formed from non-living chemicals, a process called abiogenesis. It might be a 1 in a trillion event, requiring such a precise and unlikely series of chemical reactions that it has only happened once in this galaxy, here on Earth. Or maybe the filter was the leap from simple prokaryotic cells to complex eukaryotic cells, a step that took nearly 2 billion years to happen on our planet. If either of these events is the great filter, it means we are extraordinarily lucky. We have passed the great test. It would make us one of the first, or perhaps the only, intelligent species to have ever existed in our galaxy. But there is a much more frightening possibility. What if the great filter is not in our past, but in our future? Perhaps civilizations inevitably reach a point where they develop the technology to destroy themselves, and most of them do. This could be through nuclear war, an engineered pandemic that escapes a lab, a runaway artificial intelligence that sees its creators as a threat, or irreversible climate collapse. This would mean that the journey to becoming a stable, multi-planetary species is a tightrope walk over an abyss, and almost everyone falls. The silence we hear from the cosmos would be the silence of graveyards, the final testament of countless civilizations that reached our level of technology and failed their final test. The implications of the great filter are profound, and both possibilities are unsettling. On one hand, if the filter is behind us, it means we are one of the rarest things in the entire universe. It places an immense weight of responsibility on our shoulders. We would be the sole guardians of consciousness in our galactic neighborhood. On the other hand, if the filter is ahead of us, then we are likely doomed. It would suggest that our current global challenges, our conflicts, our environmental impact, our experiments with powerful technologies, are part of the great test that has extinguished countless others. The silent stars would be a warning, a glimpse into our own probable future. Let's explore a different, more paranoid explanation, the dark forest hypothesis. This theory, popularized by author Liu Cixin, paints the universe not as an empty cradle, but as a terrifyingly dangerous place. Imagine the universe is a dark forest at night. It is filled with countless silent, armed hunters. In this forest, survival is everything, because you can never know the true intentions of another hunter you might encounter. The safest course of action is to eliminate them before they can eliminate you. Therefore, every civilization in this cosmic forest must do its best to stay hidden and silent. Any civilization foolish enough to broadcast its existence is like a person shouting in the dark forest, revealing their location to every predator hiding in the shadows. Why would this be the only logical strategy? The dark forest theory is based on two principles: chains of suspicion and technological explosion. First, two civilizations can never be certain of each other's benevolence, creating a spiral of mutual distrust. Second, technology can advance at an exponential rate. A civilization that seems primitive now could become an existential threat in just a few centuries. Because of this uncertainty and potential for rapid technological growth, any unknown civilization must be treated as a future threat. The most logical, safest strategy for long-term survival is a preemptive strike. In this terrifying scenario, the silence we observe is not because no one is out there, but because everyone is hiding in fear. But what if their intentions are not malicious? Perhaps the aliens are more like zookeepers. This is the zoo hypothesis. It suggests that advanced alien civilizations know we are here, but they deliberately choose not to interfere. They might have established a galactic-wide policy to leave primitive cultures like ours alone, allowing us to develop naturally without contamination. We would be like animals in a vast nature preserve, observed from a distance but never contacted directly. They might be waiting for us to reach a certain technological or ethical milestone before revealing themselves. This hypothesis is comforting in a way, as it implies we are being protected, but it also means we are fundamentally insignificant, merely an exhibit in a cosmic zoo. Another possibility is that we are simply searching in the wrong way. Our primary method of searching, SETI, is based on listening for radio waves. This technology is only about a century old for us. An advanced civilization that is thousands or millions of years ahead of us may have moved on to far more sophisticated communication methods. They could be using technologies we can't even imagine, like modulated neutrino beams, gravitational waves, or communication through dimensions we cannot perceive. Searching for radio signals from them might be like trying to communicate with a modern office building using jungle drums. The signals could be all around us, but we lack the senses and the scientific understanding to detect or even recognize them. We are listening for whispers in a language we don't understand. Let's take that idea even further. What if a civilization becomes so advanced that it transcends its physical form and the material universe as we know it? This is the transcendence hypothesis. They might have uploaded their consciousness into a digital reality, a vast computational matrix where they can explore entire universes of their own creation. They might have learned to manipulate space-time and live inside black holes or in other higher dimensions. From our perspective, they would be indistinguishable from the laws of physics. Their goals and existence would be so far beyond our own that interacting with us would be as pointless as us trying to have a conversation with an ant. We are not being ignored. We are simply and completely irrelevant. Perhaps the most straightforward answer is the most humbling one. The universe is just too big. The distances involved in space travel are mind-boggling and may represent an insurmountable barrier. The nearest star to our sun, Proxima Centauri, is over 4 light-years away. With our fastest current technology, it would take us about 80,000 years to get there. Even if a civilization developed technology to travel at a significant fraction of the speed of light, colonizing an entire galaxy would take millions, if not hundreds of millions, of years. It's possible that the galaxy is full of life, but everyone is effectively isolated on their own little islands, separated by an uncrossable cosmic ocean. They aren't visiting because they simply can't. This leads us to the rare Earth hypothesis. This idea proposes that while simple microbial life might be common throughout the universe, complex intelligent life is exceptionally rare. The sequence of events that led to humanity's existence on Earth required an incredibly long and specific list of fortunate coincidences. We needed a large moon to stabilize our planet's axial tilt, creating stable seasons. We needed a gas giant like Jupiter to act as a cosmic vacuum cleaner, protecting us from constant asteroid impacts. We needed plate tectonics to regulate our climate and a strong magnetic field to shield us from deadly solar radiation. The hypothesis argues that this perfect combination of factors is so statistically improbable that it may have only happened once. If the rare Earth hypothesis is correct, it leads to the loneliest and perhaps most profound conclusion of all. We are alone. Or at the very least, we are the first intelligent species to arise in our galaxy. In this vast, silent cosmos, humanity could be the only flicker of self-aware consciousness. This idea transforms our perspective entirely. It means there is no one coming to save us from ourselves, but it also means that all the beauty, art, and science created by humanity is utterly unique. It places a monumental responsibility upon our species. We would be the universe's sole opportunity to understand itself. Our future would not just be our own, but the future of intelligence in the entire Milky Way. So, where does that leave us? The Fermi Paradox presents us with a fascinating but frustrating mystery with many possible solutions, each more thought-provoking than the last. Are we alone because of a great filter or the sheer rarity of Earth-like conditions? Do we live in a dark forest where everyone is forced to hide in silence to survive? Are we an exhibit in a cosmic zoo, being watched by unseen guardians? Or are we simply too primitive to comprehend their existence or the vastness that separates us? Each of these theories reflects our own hopes, fears, and limitations as we try to understand our place in the cosmos. For now, the great silence persists. The paradox remains unsolved, a cosmic question mark hanging over our civilization. But the search for an answer is one of the noblest things we can do. It drives our science, fuels our imagination, and forces us to reflect on the future of our own species. Every time we point a telescope toward a distant star, we are participating in this grand quest. So the next time you look up at the star-filled night sky, don't just see points of light. See the possibilities, see the mystery. The silence of the universe might not be empty. It might be full of answers we are not yet ready to hear. And the question will always remain, urging us forward. Where is everybody?